Hello everyone. Yeah, we have another question on what we call thermal physics. Now, the question we have before us is we have when a driver brakes an automobile, the friction between the brake drums and the brake shoes converts the car's kinetic energy to thermal energy. So when brakes are applied to the what? Automobile, okay? The friction between the brake drums and the brake shoe, okay, bring about energy conversion, from kinetic to what? To thermal energy. That means the energy is converted from kinetic energy into what? Thermal energy. So if a 1,500 kilogram automobile traveling at 30 meters per second comes to a halt, how much does the temperature rise in each of the 8 kilogram iron brake drums? Now we're given the specific heat capacity of iron to be this. Okay, so now because we have in the question that the car's kinetic energy, that is the friction between the brake drums and the brake shoe, convert the car's kinetic energy to what? To thermal energy. That is, because of the moving part generates heat, and that's why the energy transformation is from kinetic energy to what? To thermal energy. So the first thing is to calculate the kinetic energy. So when we know the value of Ke, that is the kinetic energy, then because the the friction between the brake drum and the shoes and the brake shoes, bring about energy conversion from kinetic to what? To thermal. So we can say that the value of the kinetic energy is equals to the value of what? Of the thermal energy. So let's find out. Okay, so step one. Step one, calculate the kinetic energy. Calculate the kinetic energy. Now we know that kinetic energy is 1/2 of mass times velocity square. Okay, that's speed raised to the power of 2. So we know that mass of automobile is 1500 kilograms. Then we also have speed of automobile. The speed of automobile is 30 meters per second. So the kinetic energy will now be 1/2 multiplied by the mass of automobile, which is 1500, that's 1500 kilograms. Then the speed, that will be 30 raised to the power of 2. 1500 divided by 2, that will be 750. So we have 750, okay, 750 multiplied by 900. Okay, 750 multiplied by 900. So 750 multiplied by 900, that will be 675,000. So this is kinetic energy. So the kinetic energy will be 675,000 joules. So this is the kinetic energy of the what? Automobile. So the kinetic energy, the car's kinetic energy changes to what? Thermal energy. So which means we can say that the kinetic energy changes or converts to what? To thermal energy. To thermal energy. So which means that Ke is equals to what? Thermal energy. So which means that the thermal energy, okay, the thermal energy of the automobile, that's of the brake drum, will now be equals to this value. So it will be 675,000 joules. That is 675,000 joules. That's the thermal energy. So because we want to find out how much does the temperature rise in each of the 4 8 kilogram iron brake drums. Now this is what we're going to do. So in each, so that means we'll need to what? We'll need to calculate the thermal energy absorbed by each brake drum. Yes. So step two, calculate the thermal energy absorbed by each brake drum. So the thermal energy absorbed by each brake drum will be thermal energy per brake drum, and that will be this value. Okay, this value divided by what? By 4, because we have 4 8 kilogram iron brake drums. So which means we are going to calculate. So we want to calculate thermal energy per brake drum. So thermal energy per brake drum will be Q, this guy, over what? Over N. So where N is the number of brake drum, which is 4. Now we know that Q is what? 67500 joules. So the thermal energy per brake drum will be equals to, so we have 67500 over what? Over 4. So let's get the value. So when this is divided by 4, so we have 168750. Okay, that'll be 168,750 joules. So this is the thermal energy per what? Thermal energy per brake drum. That is the thermal energy absorbed by each brake drum. Okay, so that's step 2. Now, then finally, let's calculate the what? The temperature rise, because we want to know the temperature rise in each of the 4 8 kilogram iron brake drum, and we just calculated the thermal energy absorbed by each brake drum. Okay, so since there are 4 brake drums, okay, so which means the energy absorbed by each brake drum will be thermal energy per brake drum, and that will be this value, which is the thermal energy. After we know that after we know that the kinetic energy of the car changes to what? Thermal energy. So the value we got from here, which is same thing here, okay, divide by 4, and that's what we have here as the thermal energy per brake drum. So now step 3. So we want to calculate temperature rise. Okay, we want to calculate temperature rise. So that will be delta T. Okay, to calculate temperature rise, so we're going to use the formula for calculating specific heat capacity. Okay, so and we have specific capacity of iron. So in this case, we're going to use Q equals to MC change in theta and temperature. So the temperature rise will be, this is the temperature rise. We have the temperature rise. Okay, so the temperature rise will be equals to Q, which is the thermal energy, okay, over the product of mass of iron and what? Specific heat capacity of iron. Now, we know that Q, the value of Q is 168,750 joules. Then the mass of iron is 8 kilograms. Then we're also giving the specific heat capacity of iron to be 448 joules per kilogram per degree Celsius. So let's plug in the values, so that temperature rise will be 168,750 divided by 8 multiplied by 448. Okay, so that the temperature rise will be, so let's get the value of what is 8 multiplied by 448, and that's 3584. That's 3584. So we have 168,750 divided by 3584. Okay, so let's get the value of the rise in temperature. So we have 168,750 divided by 3584. Okay, so that will be 47.08. Now this will be in degrees Celsius. So the temperature rise will be 47.08 degrees Celsius. So the temperature rise will be approximately 47 degree Celsius. So this is the temperature rise in each of the four 8 kilogram iron brake drum when the specific heat capacity of iron is 448 joules per kilogram per degree Celsius. The noblest pleasure is the joy of understanding. Bye bye.